to another edition of my channel, Chemistry with Mr. Jha. In this video, I'm going to talk about concentration of solutions, which is the basic and it is the basis for the study of further chemistry. Because the upcoming chapters in your syllabus will revolve around these calculations, that is concentration of solutions. There is a chapter on solutions in which we will require the concentrations to be calculated, and concentrations will have a very, very deep meaning here. The most common ways of expressing the concentration of solutions are as follows. Molarity, here in yellow, is equal to number of moles divided by volume of solution in liters, and this means that the solution carries both the solute and the solvent, and the volume is measured for both of them. So number of moles divided by volume of solution in liters. If number of moles is 1 and the volume of solution is 1 liter, molarity is 1. We will see these things used in practical examples as we proceed in the lecture. The next is molality, which is equal to moles divided by kg of solvent. Here the solvent is measured separately in terms of kg. Here we have volume, here we have kg. Moles remain constant in both. And therefore, since kg of solvent is used here, molality is a better way of expressing concentration. The reason is the mass does not change with temperature, but volume changes with temperature. Then we have formality with grams of 1 unit formula of substance divided by volume of solution. Then we have normality, in which we use equivalents, number of equivalents divided by volume in liters of solution, as we did over here in molarity. But we use molarity, here we use equivalents, number of moles here, and this is equivalents. So one equivalent weight of solution is known as 1 equivalent. Suppose we have 23 grams of sodium. So 23 grams of sodium is 1 equivalent of sodium, and if it is dissolved in 1 liter of a solution, then its normality will be 1. The simplest way is grams per centimeter cube, or grams per milliliter cube, and we know that 1000 milliliters is equal to 1 liter. So it becomes kg per liter, or grams per centimeter cube, or grams per millimeter. So these are some of the most common ways of expressing the concentration of solutions. But usually we use molarity, grams per centimeter cube, and molality. Formality is used in some numericals. Normality is used but is related to molarity. Let's see some others. The others are mass fractions and mole fractions, which are also used to express concentrations. This letter, this Greek letter A, is equal to, or the mole fraction of A in a solution which comprises A and B as its component, is number of moles of A divided by total number of moles, that is number of moles of A plus number of moles of B. Similarly, mass fraction of B is number of moles of B by total number of moles of different components in the solution. Here the components are A and B, and Na and Nb are number of moles of A and B in the solution. If a solution is made up of A grams of A and B grams of B, then the mass fraction of A can be written as Ma equals A, which is mass of A, divided by mass of A plus mass of B, which is total mass of the mixture or the solution. So this usually is used in, or can be made use of, in solid mixtures, because in a solid liquid mixture the solid will be there. It may be in the same phase as the liquid or may not be in the same phase as the liquid, but liquid has to be measured in terms of liters or centimeter cube or milliliters or deciliters, whatever it may be. Now this done, we take a look at some of the numericals which are based on these, not on all the formulas, but I have selected some tough type of numericals which will help the students to understand how to use the formulae in solving the problems. So problem number 1, a solution of H2SO4 has a molar concentration of 8.010 molal, this small m is molal, and a density of 1.354 grams per ml, which is centimeter cube. What is the molar concentration of the solution? So molar has been given, molar has been asked. The answer is as follows. 8.010 m solution means that there are 8.010 moles of H2SO4 dissolved in 1000 grams or 1 kg of water. We know that density is given by mass over volume, the ratio between mass and volume. So the mass of the solution is equal to D into V, transposing V on the left side, 1.354 into 1000 ml, assuming that 1000 gram of water at normal room temperature measures 1000 ml. We get the weight of the solution or the mass of the solution as 1354 or 1354 grams. Now 8.010 mH2SO4 means or is equal to 8 into 98. 98 is the molecular weight of H2SO4. Multiplied by 8, it gives 784 grams of H2SO4 present in 1354 gram of solution. Therefore, the weight of water is mass of solution minus the mass of the solute, which is 570 grams, roughly 570 ml divided by 1000 to convert it into liter, which is 0.570 liter, about half a liter. Molarity, the formula is number of moles by volume in liters. So number of moles is the same, 8.010 divided by 0.570, and the answer comes to 14.05. The reason why we have to convert this into kg is to find how much water is present, and that has to be converted into liters, because molarity uses volume in liters and molality uses mass of solvent in kg. So 1 mole of H2SO4 in 1 kg of water is known as 1 molar. We now go to see another numerical. What is the molality of a 3.75 m H2SO4 solution with a density of 1.230 gram per ml or per centimeter cube? So this is the strength of the solution, or concentration of the solution, is also known as strength of the solution. The molecular weight of H2SO4 is 2 into 1 because hydrogen atomic weight is 1. 32, we have only one S, so 32 into 1 is 32. And we have 4 oxygens, so 4 into 16 is 98 grams mole inverse. 1 mole of H2SO4 is 98 grams. Now the answer is as follows, or the way we arrive at the answer is as follows. 3.75 m solution means 3.75 moles of H2SO4 dissolved in 1000 ml or 1 liter of solution. D equals m by v, or ratio between mass and volume of the solution. So the mass of solution D into V is equal to 1.230 into 1000, which means it is 1230 grams. There are so many ml, and the density is 1.23 gram per ml. So for 1000 ml, this is the mass. Grams of H2SO4 is 3.75 into 98, that is 367.5 grams of H2SO4 is used. The weight of water used is 1230 minus 367.5, which gives us 862.5 grams of water involved or used. And this gram of water is divided by 1000, so it is 0.8625 kg of water. In molality, we use kg of water, as has been shown earlier. So molality, number of moles by kg of solvent, number of moles is 3.75. It remains unchanged. And from this calculation, we have water whose mass is 0.8625 kg, and dividing 3.75 by 0.8625 kg, we have 4. So molality is 4. On to the next question. How many grams of hydrogen chloride are required to prepare 4 liters of 5 m HCl in water? Answer is as follows. The molecular mass of HCl is 1, that is the atomic weight of H, and Cl, which is the atomic weight of chlorine, 35.5, and the total mass, molecular mass, is 36.5 AMU. The molecular weight, therefore, is 36.5 gram mole inverse, because molecular weight is nothing. Molecular mass expressed in grams is molecular weight. Molality, as has been discussed earlier in the 2 problems and also in the first slide, is number of moles divided by volume in liters of solution. So molality given is 5. Number of moles is to be calculated. Volume is 4. And transposing volume to the left side, we have 5. Molarity multiplied by volume 4, 20. So number of moles of HCl should be 20. But the question says how many grams of hydrogen. chloride. Therefore, strength in grams is moles into molecular weight. The number of moles is 20 as has been calculated here, and molecular weight is 36.5 grams, and the answer is 730 grams of HCl will be needed to make 4 liter of 5M solution. So changing one unit into another, you see, mostly we are using moles and molarity. We can use normality also, but as the trend shows, I have done this video explaining how moles and molarity, strength in grams equals moles into molecular weight, can be used in different problems. Now, what makes this problem interesting is there are two formulas, you see, molarity and then strength in grams. Right, there's no molarity given here. In the previous two, we had molality or molarity given, from where we had to find either molarity or molality. On to the next one. How many grams of sodium dichromate should be added to a 50 ml volumetric flask to prepare 0.025 molar sodium dichromate when the flask is filled to the mark with water? The formula of sodium dichromate, which one is expected to know if it is not given in the question. Otherwise, sometimes the question, you see, a comma is placed there and the formula is given alongside, so there's no problem. But anybody in grade 12 who's going to answer CBSE must know the formula. There cannot be any excuse not knowing the formula of the substance given here. The formula must be known. The other things will be given, atomic weight and other things will be given, so the calculations can be made from them. The formula of sodium dichromate is Na2Cr2O7. So answer is, when the flask is filled to the mark, it will contain 50 ml of solution, that is 50 by 1000 of 0.05 liter of the solution. Now we know that molarity is N by V and V is measured in liters. So we have to convert this into liters here. Or molarity is given 0.025. So we place the value of molarity here, equals N, we don't know. So we keep it as N divided by 0.05 L, which is converted here. Or N is equal to, by transposing, 0.025 into 0.05, which is 0.00125 moles of Na2Cr2O7, which is required. Molecular weight of Na2Cr2O7 is 2 into 23. 23 is the atomic weight of sodium. 2 into 55, 55 is taken as atomic weight of chromium. 16 is the atomic weight of oxygen into 7, and the addition yields 268 gram per mole of Na2Cr2O7 or sodium dichromate. Now strength in grams, which is required, as it has been asked, how many grams, is equal to number of moles into molecular weight. The number of moles is this, as calculated here. Molecular weight of sodium dichromate is 268, and the multiplication of 2, or the product of 2, is 0.335 grams of sodium dichromate. I hope these explanations were to your liking, and they will help you in calculating many such other problems, the answer to such other problems. Do subscribe, like, and comment on what I have spoken here. If you have any problems, please post them. They will be solved immediately and posted back on the channel. Thanks for watching. Enjoy chemistry. Have a nice time.